Hey folks, Iana Kone here. Thought I'd walk through this word problem here. And I've talked about a handout that I've given you called the flowchart for solving word problems. And it really does help. But this one, I've refined it a little bit. And I think this is easier to understand. So you follow this process, do what I say, and you'll get every single one right. You really, truly will. And so the first thing you do, here we go, is how many grams must be given to a patient who weighs 220 pounds. So, a patient needs 62 milligrams of medicine per kilogram. There are 2.2 pounds in 1 kilogram, round to the nearest hundredth. So this problem has everything. Level 2 means everybody in this class should be able to do this one by the end of the year pretty easily. A level 3 is like a B problem, maybe a B plus, but we should all be able to do this one eventually. First step, I took all of the conversion factors. There's a 62, boom, put it on the top, put it on the bottom, put it on the bottom, put it on the top. Look, there's another one, conversion factor. 2.2 on the top, 2.2 on the bottom. You put it in a box, you put the word or between it. This one is not given in the problem, but typically you're going to have to do a little conversion within the metric system. And the clue is, look at this. The problem is how many grams must be given, but the medicine is in milligrams. So that's a clue that, oops, sorry folks. And that's a clue that you're going to have to convert from grams to milligrams. So you put the 1,000 on the bottom and you put the 1,000 on the top. And later I'll show you in this problem why you need that one. If you don't, if you can't put it in these boxes now, then you can do it later in the problem. So first step, what are the units of the answer? It truly is, that is the question. I've had so many students want to start it another way and whatnot. And you can, of course, but do this every single time and you'll get it right. That's what you do. That's the step. There's the word gram. So B, start with the given amount. That's what you do. And then gram. Now, lots of people will ask, well, how does this solve the problem? Well, I'm going to talk about that during the problem, but I've seen students get really, really so concerned with how to solve the problem, they don't start. So start here. And then the next step, because it says first conversion factor must have pounds in the denominator. That's the directions every single time. Whatever word is here in the numerator, you find the appropriate conversion factor with pound with the same word in the denominator. That every single time, that is just exactly what you do. Now look up here. I'm looking for pounds in the denominator. Nope. It's got that one. So on your paper, you'd put a check here or X it out. You don't use that box anymore. So then we've converted that out. Now, how this is solving the problem. We started with the person weighed 210 pounds, and this conversion factor allows us to convert that to kilograms. Well, notice kilogram and grams are really close, the same words. This is how this is solving the problem. We're converting from one unit to the other units with the conversion factors. So the next step, second conversion must have kilogram in the denominator and one that you haven't used. So memorize this process. Look at here, 1 kilogram on the top, 1 kilogram in the bottom. It's as straightforward as that. Now let's choose the right box. It's this box right here. We use this box already, put a check on it. And we're looking for kilogram in the bottom. Yep, put a check on it, don't use that again. You put 62 there and you cancel it out. So we're converting from pounds of patient, now kilograms of patient. Now this conversion factor is taking into account for every kilogram of patient, it takes this much medicine. And look, milligrams and grams, we're closer. So let's look at the next step. The final conversion factor must have milligrams in the denominator. You'll have to find this one on the equation handout. So notice that we have milligrams on the top. We need milligrams on the bottom. Well, that isn't given in the problem, but here's how to figure it out. Look, we have milligrams, which is a weight in the SI units, and then you have grams. So that's your medical mass unit. So hopefully that's the clue to look in your conversion factor or your conversion sheet. Put milligrams on the bottom, put grams on the top. Now look what happens when you cancel everything. Pounds and pounds cancel, kilograms and kilograms cancel, milligrams and milligrams cancel, and you're only left with the word gram, which is the answer, and that's the answer. Now, I like to do my math separate. I'll write all the numbers separate. I do, and I've been teaching this stuff for 35 years now. Write it separate because you're going to make mistakes with all these numbers, all these cross outlines, and the words. You're going to miss one of those numbers that you just will, or you can. So I did my multiplication and division. The problem says round it to the nearest hundredth. So the hundredth place is the 1 right there. And then we want to make a rounding decision based on this number, the 8, which is in the thousandths place. The rule is if it's a 4 below, leave the number alone. If it's a 5 or above, round up. So it's an 8, so we round up, so it's 5.92. Bam, look at that.